Okay, so these are notes that we actually went over and did in class already because it's been a few weeks. For those of you who were absent or who just really don't remember what in the world happened before we left school, I wanted to just do a video so that way you could go back and reference this along with your notes and along with the notes that I posted, just so you have another resource for this. So looking at the very beginning of the Unit 3 packet on page 2, okay, solving a system of equations by graphing. There are going to be 3 methods that we use in this unit. Graphing is the first, and it really is the most straightforward, okay? All you're going to do is, as I have written here, graph both lines and then find the point where they intersect. We're going to name that point of intersection because that point of intersection, as you can see right here, that ends up being the solution. Okay, the solution is where the points intersect, which means that that solution is going to be an ordered pair. Okay, so very simple, graph both lines, find where they touch. So the first equation here, y equals negative 4x plus 8, remembering that when we graph lines in y equals mx plus b form, okay, we begin with b and we move with m. So this plus 8 right here means we begin 8 units above the origin. 1, 2, 3, 4, 5, 6, 7, 8. And a slope of negative 4, that's going to then be down 4, right 1, down 4, right 1. You're going to want to do this as many times as you can because you don't know where the lines are going to intersect. Okay, if I could have gone in the opposite direction by going up and left, I would have, but I don't have enough room on this coordinate plane. So then I connect. It's not the best line ever. I'll try again. And now on the same coordinate plane, we're going to graph the other line. Just erasing those other points that I wrote on there just to count out for you. Okay, for this next equation, y equals 2/3 x minus 6, we begin with negative 6, which means we begin down 6 units from the origin. So down, I'll use a different color here, 1, 2, 3, 4, 5, 6. And then we move with m. Our slope here is 2/3. That means up to right 3, up to right 3. And I do not even need to keep going because I've already found the solution. Okay, this point right here is the point that lies on both of those lines. All that needs to be done now is name that point. Okay, the coordinates of that point, remember points are x, y. The x coordinate of that point is 3, and the y coordinate is negative 4. So those 2 lines cross at the point 3, negative 4. So that would be the solution. That is the only point that lies on both of those lines. It's really that simple. You graph both lines, find where they touch, okay? Only difference, looking at example 2, okay? In this case, neither of those lines are in y equals mx plus b form to begin with. So we need to get them in that form. So looking at this first equation, remember our goal is to have the equations look like this. Y equals mx plus b, because we can simply then begin with b, move with m to graph our line. So the difference between what we want and what we have is that y is not isolated. To get y isolated, this negative 2x needs to go away. So we're going to add 2x to the other side. That means we'll now have y equals positive 2x minus 3. Okay, and then we can graph that line. To graph that, we begin with b. We begin down 3 units from the origin, and we move with m. Positive slope is up and right. Specifically in this case, it's up to right 1. We go back to the beginning. Opposite of up and right is down and left. And hopefully you drew a better line than I just did. Connect. Okay, we now need to get this second equation solved for y. Again, we're trying to get y isolated. Y is not by itself. So to isolate it, we would need to move this 3 to the other side. That 3 is currently multiplying y, and the opposite of multiplication is division. Don't play favorites. Make sure you divide everything on both sides by 3. Okay, on the left, 3 divided by 3 is 1. 1y is just y. On the right, we have our 4 x divided by 3, that's just 4/3 x. And then our negative 3 gets divided by 3. That's negative 1. And now we can go ahead and graph this. I'm just going to copy it so I have it here for when I'm graphing. So we begin with b. This negative 1 means we begin down 1 unit from the origin. And that slope of 4/3 means we're going to, from that point of negative 1, move up 4, right 3. Up 1, 2, 3, 4, right 1, 2, 3. We can see right away where they cross. Okay. This point right here lies on both the lines. The only thing left to do is to name the coordinates of that point, and that point has coordinates 3, 3. 3, 3 then is the solution to this system. That's the one point that lies on both of those lines, okay? You can see in both of the examples I've done, there have been one solution. In this first one, the one solution was 3, negative 4. In example 2, the one solution was 3, 3. Okay, there are some special cases though. Same thing goes for when we're solving linear equations. Typically there's one solution, x equals 7 or x equals 5, whatever it happens to be. But we know that sometimes there's no solution. Sometimes we have all real numbers, which means there's an infinite amount of solutions. In this case, when we're solving a system of equations, we have the same special cases. And we'll see that happen if two lines have the same slope, okay, and they have different y-intercepts. That makes them parallel. And if they're parallel, they don't touch, which means there's no solution. Okay. If, however, we have two lines that happen to actually be the same line, well, there's an infinite amount of points on every line. So if we have one line graphed right on top of the other, that means they have an infinite amount of points in common because they have every point in common. That would be infinitely many solutions. So let's take a look at these examples. For example 3, the first line we can graph as is, y equals negative x minus 3, right? We begin with b, so we begin down 3 units from the origin. That slope of negative 1 is really a negative 1 over 1, so that's down 1, right 1. So far, we've done nothing different with this system than with the other two. Here, y needs to be isolated, right? We need this in y equals mx plus b form. So we're going to go ahead and subtract x from both sides. And that gives us y equals negative x plus 1. So to graph this, we begin up 1 unit from the origin, and then that slope is really a negative 1, which is a negative 1 over positive 1. So down 1, right 1, as many times as we can. Going back and going up and left. You can probably see what's occurred at this point. Okay, right? Two lines that lie in the same plane but don't intersect are parallel. And if we are looking for the point of intersection and parallel lines have no intersection, that means there's no solution. So when we see that we have parallel lines, automatically tells us there's no solution. Okay, re-examining this system that we had, y equals negative 1x minus 3 versus y equals negative 1x plus 1. Okay, in this case, oops, sorry. We have same slope, but different y-intercepts. When that ends up being the case, when the slope is the same, but the y-intercepts are different, that tells us automatically the lines are going to be parallel. Okay, so for some of you who are probably already pretty good at this, just from remembering it from previous classes or even from when we did it a few weeks ago, you may already be able to just look at a set of equations and tell right away if there's going to be no solution. If you see same slope, different y-intercept, that tells you this, that they're parallel, which automatically means there's no solution. You could figure that out without even having to graph them. And looking here at example 4, that first equation we can graph as is, y equals 3x minus 2. So we begin down 2, slope of 3. So we're going up 3, right 1. Down 3, left 1. In the second equation, we have a few steps to do. I'm just going to write this here. Okay, we have a few steps to do in order, I don't know what is going on with my iPad right now, to isolate y. Okay, to isolate y, we have to move both the 9x and the negative 3 to the other side, and we do opposites. Okay, we're going to go ahead and subtract 9x from both sides, giving us negative 3y equals negative 9x plus 6. Y is still not isolated, so we're going to go ahead and divide by that negative 3 that's multiplying it, giving us, well, negative 9x divided by negative 3 is a positive 3x. 6 divided by negative 3 is negative 2. If you notice, this equation and the first equation that we graphed are exactly the same. So if I went ahead and graphed that line, I'm going to be at the exact same points that I was when I graphed the first line, because they are the same line. They have every single point in common. And if there are an infinite amount of points on a line and they have every point in common, that means there are infinitely many solutions. So if they are the same line, automatically you know there's infinitely many solutions. If they're the same line, everything is the same. Slope is the same, and the y-intercepts are the same as well. Okay, those are all the types that you would possibly see if you are solving a system of equations by graphing. Okay, again, one solution you can see in these first two examples. We have two lines, we graph them, we find the point where they touch. There's one solution there. We have some special cases. We graph the lines, and if they don't intersect, the only type of lines that lie in the same plane and don't intersect are parallel, right? If they're parallel, there's no solution. If they happen to be the same line, we have one line on top of the other, there's then an infinite amount of solution.